with, and that again is based on just the time frame that we have today to do this. All right, so we'll dive in. So what you're seeing here is where to find more information. When the software is installed on your PCs, you can have an icon on the desktop that is OpenLAB Help and Learning. And once you go into that icon, you're going to see the opening page, and there's just a vast amount of information on this Help and Learning. And another thing that I'm going to try to do throughout the presentation is to show you the F1 function of the software. So when you do F1, depending on where you're at in the software, you'll actually pull up Help and Learning, which is context specific. So if you're in building a sequence table and you hit F1, you'll go into Help and Learning for sequences and actually building in the tables. If you're in data analysis, building a calibration curve, and you hit F1, it'll be specific to the calibration table and how to build it. So the one thing about the Help and Learning is it's a really, really good first line of defense of troubleshooting. If you run into something where you just have questions or you're just wondering maybe what's the definition of this, F1 is a great starting point to find this out. Also, there's PDFs on the USB media sticks that come with the installation. So there's manuals, reference guides, user guides, just a ton of information on the actual foundation of the software and what it can do, applications notes, all that good stuff that just kind of can help you along with any questions you have. All right. There's also a ton of demo data. So the demo data that you're going to see in this today is available on the media that you got with the installation of the software. So the way you can find that is if you're going to set up, tools, support, and then demo data, there's example data. So this is how you can actually take these recordings in the future and actually use it with some of the data that you have on your own system. Okay, so the CDS workflow. The first section really goes over creating a project, creating and configuring instruments. So we're assuming that that is all set up at this point, right? So now, today we want to talk about creating the acquisition method, what all is involved, creating the data processing method, as well as what all is involved there. All right, so when you're creating an acquisition method, you can run single injections and you can also do sequence runs. So we're going to address the differences of both of those, the file structure of both of those, and then we're also going to process this information. We're going to look at the integration tables, identifying compounds, building a calibration table, as well as printing and where you can send the reports that you generated. So this slide is just to kind of give you an overall workflow of what we're doing. Okay, so for data acquisition, we're going to create an instrument with a specific method. All right. Again, it may sound obvious, but you have to have a method with certain parameters when you want to acquire your data, right? That's specific to your application. So with this software, you have a suffix that is AMX, and that is for acquisition method. If you're coming from ChemStation or if you're coming from EasyChrome, you'll notice that some of the suffixes are different. And what I'll try to do is I'll try to address all of these suffixes so that you have an idea of what the different file structures are happening in the background, which will really overall help you understand the flow of what's going on with the data side of the software. All right, so an acquisition method is .amx. When you run a single run, it's going to generate a result that is .si RSLT, right? .si result. And then when you do a sequence run, you're creating a result set. So sometimes you'll hear me, instead of saying a sequence result, you'll hear me say result set, and that's going to create a .RSLT. All right, so here you can see just the user interface of the method layout. You've got an acquisition method, and in this case, it displays the current acquisition method that's loaded, right? The current .amx that's loaded into the screen. And then it goes through and it gives you all the instrument-specific set points. So we're going to take a look at this in the demo. But if you load up the acquisition, maybe for the first time, right? This is the first time you've configured let's say an LC or a GC, and you're loading up for the first time, and you go to this method layout, you're going to see a default AMX. So once you make your changes into your parameters and then save those, then that new method AMX name is going to be displayed at the top within that red box. All right, so running a single sample result, it's going to generate, again, a .si RSLT file. So this displays the single sample layout, right, where you have an acquisition method that is required to be input. All right, so if you're about to run a single injection and you don't have anything in the acquisition box, the green run box will not be displayed. It'll be grayed out. So you'll have no way to actually submit this single run. All right, but once you put in your acquisition method, then you have a bit of information that's also here with its sample name. You don't have to have a sample name, so the sample name can be blank, right? And then you have a result file name. So the result file name, you don't have to put anything there, but it's going to, if it's blank, it's going to create a default result file name. All right, but again, you don't have to put anything there, but it is going to generate a default result file name. And what that default result file name, it's going to be instrument name, date, and a time format. So it's basically going to be an instrument name and then a timestamp based on the tokens that it chooses. Now, the sample name and the result file name, both of these, as you can see, have little arrows to the right of the box, and what that means is they're token specific. So you can go in and you can add these tokens, say like a timestamp, a sample name, an instrument name, a lab name, a project name. There's different tokens that you can input into this area if you choose to use that as your naming scheme. So again, we're going to see this more in the demo to actually home in on this. All right, and then the sequence run, what that does is that generates the .rslt file. All right, so at the top of your sequence table, you're going to see what's currently loaded. So what's outlined in red, that is the currently saved sequence run that includes these 4 individual injections. All right, so again, just like running a single run, when you create a sequence table, it's going to require a .amx file. So again, it requires an acquisition method in order to even be able to hit run, right? So that is the big requirement when it comes to the sequence table. And again, for the sequence, there's a new feature in the CDS 2.2 where you can have a token name for the result file. So at the bottom of this slide, you can see where you can adjust the result path and you can add a result name. So this is new for this version, that in the result name, I can now I can type in whatever I'd like to type in. So it can be specific to what I want it to be, or I can add tokens. All right. So just like running the single injection, if I leave the result name blank, it's going to take the token's instrument name, a date, and a time as the result name. Okay, as the result set name. So this brings up a good point where for this example on this slide, I've got 4 runs, right? I've got 4 runs that were injected into one sequence. You have result file names for each individual injection, and then you have a result set name that is found down at the bottom of the sequence run. So it's going to be important not to get those mixed up when you're running sequence runs. And what I'll do again, I'll show you this again during the demo, but I did want to make clear that you have the ability to name result file names for each one of those injections, and then you have the capability of a result name down at the bottom of the sequence, which is result set name. Okay. So another new feature with this software is the snapshot. A lot of people like using snapshot because especially for those, especially for the GC, some of the GC acquisitions can be 30, 40 minutes long, and you want to just look at something that's in the first 10-minute range. You can go into a snapshot, and what that does is when you're in the online signals, the camera populates, all right? It's usually grayed out before this happens, but it populates, it shows up, you can click on it, and what it does is it pulls up a snapshot review data analysis window. And this will allow you to analyze everything that's up to that point that you took the snapshot. Okay. One thing to point out in this is the user has to have permission to do this. If you are working on a system where For the demo and the system you're going to see online today, I don't have logins. I don't have individual users. But if you're working in a lab that's regulated, each user has to sign in. The user has to have permission to be able to access and open up a snapshot. Because what happens when you have a snapshot is you're creating another file, right? Every snapshot you do adds on a file. So I'll try to show you this more and more as we go, but that is why you have to have permission. So some people don't want a user to go in and say, I don't know, snapshot 4 or 5 times during one run, because now instead of having one result file for that run, I'm going to have the final result file and then 4 snapshots that someone took. So that's one thing to keep in mind about the snapshot is it does add an individual file for that result. Now, there's a prefix on that file that says snapshot. So you can, once you're looking at your result set, you can immediately see the snapshot. So it's not like you have to browse through just to find that file. You will be able to look through your result set and see, okay, these are the snapshots. I can either delete them, get rid of them, review them, and then delete them, whatever needs to happen. But that is something that you do have to keep in mind if you're going to allow these privileges for users. Okay, so this is going to be the first demo set. So what we're going to do is we're going to set up an instrument method, then we're going to run a single sample injection, and then we're going to run a sequence, and then I'm going to take a snapshot of one of those that I start up in order to show you kind of what we just did here. So I'm going to go over to my virtual machine, all right? And so what I've got is I've got 3 instruments. I've got a GC simulator, an LC, and a data player, and we're going to be using all 3 of these throughout this session just to kind of show you the differences in these systems and to kind of cover, you know, some differences that could be between the GC and the LC with acquisition. Analysis, they're the same, but acquisition, you can have some differences. So I have linked, for example, the LC demo, I've linked this to an LC demo project. All right, the GC demo, I have linked that to a GC demo project, and the web player, I've just linked that up to a web session project with its own thing. So if you remember, if you did do the first session or if you've used these projects before, you have to, when you load up an instrument, it's loading it up based on a project that it's under, right? So you have to have it assigned a project in order to get into acquisition. So for our first one, we'll go into the demo. So here's an LC demo. I just have my real-time status of the LC system. So if we go into the method layout, all right, I've got a method here that was run previously. It's a 10-minute run. So for this example, you've got the general section and properties. So if you go into properties, this is where you can type in descriptions. All right, so maybe actually I'll fill in the description after we change some of the method just so that we know what's going on. And this is where you can access some of the audit trails. So if you have audit trails activated in your control panel, this is how you can access your audit trail, and then you can print those out and review those. All right, so below general, we've got the individual modules. All right, here's your grad pump with your flow setting, your solvent ratios, the timetable, advanced parameters, then your sampler, you've got your injection volume. So really your basic parameters for your acquisition LC method. Okay, so for this step, we're just going to take the graduate pump. Instead of 10 minutes, I'm going to do a 5-minute run. And what we have here is we'll go and I'll save this, right, from a previous training. So I will do, you know what, let's do a 5-minute run and let's actually give it a ratio. Let's do 60, and I'll just say this is methanol. So 60-40 water methanol, and change it down to a 5-minute run. All right, so maybe now that I've done 2 changes, maybe this is a good point where you want to go back to properties and actually include a description. So 60-40 solvent ratio, and let's see, 5-minute run. And so with this description, I believe you have somewhere around 4,000 characters you can use here. So you can add in as much information as you want under the description to include as to what's being tethered onto this exact method file. So once I've done the description, I can go to Save As, and we'll do just 5 minutes 60/40. Well, invalid character, right? So you can't do dashes. So I'll just do 60/40. All right. And so you've got these two options here. One is to retrieve current method to instrument, and the other is to send to. So if I make this change into the pump, it may not have necessarily already sent it to the LC. So this becomes important if you're, I don't know, one, baking out a GC column, or wanting to, maybe you have a brand new LC column that's on there and you just want to flush some solvent through. You can set up your parameter, and I can just do in a certain flow and send it over, and I don't have to necessarily save that method. So I can just send it over to the LC and start equilibrating the column with the solvent ratio, or again, baking out a GC column. That'll help with that. So, okay, so we've got a brand new acquisition method created. All right, we go under status. Under my status, it's already sent over my solvent ratios to my pump. All right, so if we go to single sample layout, all right, we got a sample name. Let's do, let's see, 11. In 2017, okay. All right, so I've got an acquisition method that is set up. That's the one I just created. All right, if I want to go and browse for a different one, I can actually go through and then find the different one that I want to run. I don't have a processing method just yet, so we're not going to worry about that, because again, like we mentioned in the slides, I don't have to have a processing method. I only have to have an acquisition method. All right. Then you have your result path as to where it's going, and then the result name. So if I go to the arrow, these are the token options that I can select from. So there's a lot of options you can do, and you can do multiple ones. All right. I can list them out. I can do, let's say we do an instrument name. So once I click on it, it goes on ahead and populates into the result name. Maybe I want to do, I want to add the user as to who's doing this. And then the short local time. All right, so this is how now it's populated with the instrument, user, short local time. The cool thing with this is if I highlight over it, it actually gives you the little pop-up, shows you what it's going to try to create and what your file name should look like, right? LC demo, system, and then the timestamp. Okay, so now I've got everything ready to go. Sample name, result name. I can do run, and now it's sending it over to the run queue, it's validating, and now it's going to run, okay? So at the same time, let's take a look at the GC demo, all right? So if we go to the method layout of the GC, these are, if you're used to our GC drivers in the past, you can kind of see that the structure tree is kind of the same, right, because it's pulling this off of the driver of the GC. So you've got real-time information set up at the top window, so you can see what's going on with the pressure of the inlet, the temperature of the inlet, the column flow, the oven temperature. You can see all that in real time. You can also go down and actually, so if we go to oven, we can change this, and here's all of my oven information. So maybe instead of 2 minutes, you want to do a 3-minute run and extend it out a little bit, equilibration time. So these are, again, the basic parameters of your GCs, right? So here's my actual, it's now warming up to the 3000 set, or the 300 degree set point, especially if I send it over to the GC. All right, method has been modified. Do you want to save before continuing? Yes. All right, so now what I can do, all right, so now it's just sending it over. All right, so now you can see that, okay, again, this is a simulator, so the heater warmed up super quickly. This would be awesome if it happened in real time. So we're almost at 300 immediately there for the FID. So we've sent that over. Now I can save as, and I can do 3-minute run instead of a 2-minute run. All right, we'll save that. And we'll go to the injection. So same for the GC, right? You can do can just have a sample name. Again, I can leave the sample name blank if I don't want to put anything in the sample name. And then I can leave here, for this example, I'm going to leave the result name blank, just so it's going to take the default tokens for the instrument name and the timestamp. And then I can run that for the GC. Okay, and so that's kind of the similarities and the differences with the GC and the LC. Really, the only differences with both of those are going to be the actual parameters based off the drivers of the systems themselves. When it comes to sequences, single sample runs, and data analysis, they're really going to be almost identical with those two things. So if we go back to the LC demo, let's see. So we still have this running, and again, this is just a sine wave just because it's a simulator. But what I now have is I have this camera here, so I can take a snapshot of this LC run. So if I click that, it says snapshot in progress. All right, so it's loading up data analysis, and it's going to load this up in a review window. All right, while this is loading up, what I will do is I will show you the sequence. All right, so when we're running a sequence, this now, I know I'm jumping back and forth between screens. This is now my data player. All right, so I've got a data player, and what this does is it just kind of, it takes runs that are, I don't know, maybe 5 or 10 minutes down to about a minute per run, right? And it comes up with actual result files that were established when I created it. So what I'm going to do is I'm just going to pull this up. Let's see. So if we do, all right. So all this is I've got 4 runs. I've just created 4 runs into a sequence. I've got sample type. I've got my acquisition method. So this acquisition method is the one section that is required in order to make a run. Again, I don't have to have a processing method if I do a single sample or a sequence. And then you have your data file. So this is where I was explaining the difference between the file names. This is where I can create a file name based on the injection. So for here, it's just a timestamp for this first injection, right? And it's going to be the same way all the way down for these 4 runs. Okay, but this file name, this data file name, is different from the result file name, which is down here at the bottom. Okay, so I can go through here and do, we'll do webinar, and then I'll actually put a token for local time and date, and so that's going to be the name, my result name, and then local time and date is going to be the file name. So I can go ahead and run this. All right. All right, so while that is running, we will jump back to the LC that was still running, and now I have a snapshot. All right, so whenever this pop-up box shows up, what this means is you don't have a processing method linked up to the results that were just opened. So it's going to require you to make some sort of decision here. All right. For this example, we're going to be talking about this a little bit more here in just a second. So I'm just going to pick an area %. We're also going to talk about more of the differences between both of these, but for now, we'll just do a load and process so that we can actually see the snapshot. All right. So the snapshot, this is the snapshot. Here are my results. My chromatogram, again, it's not to anything, it's not anything special just because it's a sine wave, because it's a simulator. But this is how you can see the snapshot. And it was taken up to this time. And so I've got my full function of I can analyze whatever I need to analyze before that time. All right. All right, there's GC demo still going there. And that is done there. All right. Okay, so at this point, are there any questions up to what we've done so far?
Thanks, Matt. I haven't seen anything come in the Q&A box yet, but just to give folks a reminder of how you can ask questions today, you can type them into the Q&A box on your WebEx console. Or if you've joined us over the phone today, you can press *1 on your touch-tone phone, and our operator will open your line. Mia, do we have anyone that's called with a question?
No, ma'am.
Okay, thank you. And Matt, I'm not seeing anything in the Q&A at this time either.
Okay, awesome. Thank you. All right, we will just continue on with more of the data acquisition and loading samples. So this, again, we go over a couple of the information with the slides. Then we go in and we do the demo. We have some questions, and then right now what I like to do is to kind of tie in what we did on the first section, right? This becomes very useful, especially if you're looking at this this recording in the future of knowing the steps of where to go and actually get some of your data. So what did we just do? All right, we did an acquisition method. We created one with an LC. We modified one with an LC and GC. All right, we saved that as a new AMX file. All right, then we added that and used that to run a single injection. So we created an SI result file when we ran the single injection. And then we used those also to run a sequence. So when we ran the sequence, we created .rslt file. All right, and then we also took a snapshot of the LC run in order to see what is going on in the data analysis, and that it's in the review window of the snapshot. So you can see what's going on up until the point of you actually taking the snapshot of that run. All right, so for data analysis. So what we're going to cover over data analysis is we're going to look at loading the data, all right, loading single injections as opposed to loading a sequence result. All right, we're going to look at generating a process method, so creating a .pomx file. So we're not working with AMX anymore. We're working with .pomx. All right, we're going to look at integrations, how to integrate peaks, how to manually integrate, the compound identification and populating the compound table. All right, we're going to look at creating a calibration curve and then also reprocessing. So to the right here, this is a picture of data analysis F1 tool. When you're in data analysis, and again, if you're lost, if you have questions about what a term is, for example, or what a calculation is, you can hit F1 and you can actually go in, and there's just bundles of information that are segued out into different sections that you can use. So for this example, we're seeing that the calibration, we're seeing UV spectrum analysis, reprocessing, so you can just kind of dive into what section you want to use it on. Okay, so how to get to data analysis. This is a lot of people have this question, all right? So it's very common for this question. So there's multiple ways, okay? If the shortcut's been created on the desktop, you can go to the desktop and you can actually select the icon in the desktop and you can load it up that way, all right? You can also do it through the control panel. So under the control panel, if you go to the projects, and you can barely see it behind this arrow, but you go into projects, you're highlighting your projects, then you select the project that you'd like to go into the data analysis, and then you can go to the top, Start Data Analysis tab, and it'll go that way. All right, the third way is through acquisition, all right, from the run queue. So when you've got the run queue, you've got an icon with a checkbox. If you select this icon, you have the option of launch data analysis with the current project. Okay. The one thing I want to point out, all right, and this is specific to desktop icons. As you can see here, this desktop icon happens to have the name of the project. It's named Project Agilent. But when you create these shortcuts, when you create them either for an instrument or for data analysis, when you create these shortcuts, they're based on that project. All right, so say, for example, if I create shortcuts for LC-SIM, I've got the data analysis shortcut on my desktop. I may have a shortcut to the instrument on my desktop, but those, again, are pointing to the specific project. So if you're floating around different projects, you can kind of see how the desktop icons may not get you exactly where you need to go, right? So that's one thing to keep in mind when you're creating these shortcuts, is that they are project specific. All right, so this shows the data selection. So when you open up data analysis, by default, you're brought to the data selection tab. On the left side, you've got your data selection data tree, which just has all of your sequences, single injections, all of that listed out on the left side. All right, and then this is also where you can select to actually process what you need to process. So the thing, well, it's really easy to get click happy with the data analysis. But if I single click one of those sequence runs, so say for example I single click, in this example it's example data for ESTD, you click once, what that does is it pulls up the injection list. All right, so now you can see exactly all of the runs that were done in that result set. If I click twice, it's going to automatically load up what's in there and take me to the processing view. So if you just want to see what's inside of a result set, just click once. It'll pull up the injection list, and then you can double click and it'll actually go to the processing. All right, so what we just saw in my last demo is if there's not a processing method linked up to results, you're going to get this pop-up, all right? And it asks you, what sort of processing method are we going to do here, all right? We got 5 types. So at this point, you can do none, all right? You can select none, and what will happen is it'll go to the processing screen, but nothing will happen, right? Then you can kind of do some stuff from there. The good thing is, if you're confused about what is involved in these, you can highlight each one of these options, all right? You can highlight, you can just click there and highlight, and on the right side, it'll show you what you can do. So if I'm doing an area percent right now, one common thing that's not listed here is calibration, right? So if I'm doing a calibration table, I cannot do an area percent method. I need to actually go down to do one of these depending on what else is there if I'm doing a spectra. So if it's just a calibration table, then selecting the GC-LC quantitative is often a good option. All right. If you've got spectra, maybe you have LC spectra, then the 3D UV quantitative is a good option. And then if you've got a mass spec, whether a GC or an LC, the MS option will work for you there in order for you to actually do like library searches and things like that, right? So again, this is going to populate if there's not a processing method linked up to results that you just loaded. All right. So then the 2 big questions are, do I load and link data or do I load and process data? What are the differences of these? All right. So the first one is to load and link the data. And we'll see more of linking here in just a little bit, but it's to load the data, and I'm going to link it up to a method. All right. Load and process data means I'm going to load, I'm going to link, and I'm going to process. So both of these are going to link because you have to link a method. But the second option, load and process, means I'm also going to reprocess the data with that method that I just linked up there. And we'll see that more in the demo, right? So we'll see that right now. All right. All right, so we're going to do a single injection result. I'm going to show you how to load that up, and I'm going to show you how to load up a sequence result. Okay, so let me go ahead and clean some of this up. I'm going to get out of the snapshot. All right, so I want to, for the first part, do under projects, so I can get into data analysis from the control panel, and say we do LC demo, and I'll start data analysis with LC demo. Okay. I also did a sequence with the data player, and remember the data player was linked up to web session, so I'm going to load up web session and start data analysis with web session as well. So I'm going to go ahead and just load up both of those to get those going. All right, and let me make sure that, okay, everything's done loading. All right. Okay. All right, so now we are in LC demo. When we come into data analysis, it automatically pulls us to the data selection tab. Okay, so again, this is where clicking once, all right, give it a second, and then it'll pull up what was loaded. Here's my injection list within that run. Okay, and I can just kind of go through each one of these. All right, here's one with 100 injections, some more sample data, and so it just gives you exactly what was part of that. Okay. All right. So how do I guess the one thing to understand here is these. I'm looking at 4 result sets, right? But at the same time, I just ran a single injection, right? So where am I seeing my single injection? So if I click on LC demo, here are my single injections. Okay, so if I expand this, here's the one that I just ran this morning, right? So that's the one thing that we tend to get a lot of questions about. If you are where am I finding the single injections? because when you run a sequence, you're creating this package. You're creating this result set package. So it gets listed here into the data tree on its own. But with single injections, you're not creating a result set package. You're just running, literally, I'm just running that method, and I've got that one result file. So it's under this project folder, LC demo, and once I click once here, then I can actually pull that up here, web session 1, and I can load data. All right, so now I've loaded data, this one single injection, okay? And so again, this is awesome. So since I don't have a processing method linked up to this is the first time I've loaded this data, I'm getting, what do I want to do with it? Am I doing an error percent? Is this part of a calibration? Maybe I reran one calibration run. Is this UV spectra? So for our case, we'll do area percent. Actually, let's just do none. All right, I don't want to load it with anything. What happens here? All right, so if I load the data, I don't want to load anything, it's just blank. All right, it's my chromatogram, but it's nothing else. All right, so I'm going to go back here, and what I'll do is let me close this. If I right-click, you can close select injection. So let me close this and show you back in data selection. If I reload that one, and again, I didn't have a method part of it, and I go to area percent. All right, so now I can do area percent. I can load and link, load and process. Usually for new users, by default, we just do load and process for new methods. So if I load and process, all right, you'll see that it actually tried to integrate something. All right, it tried. We haven't done anything with integration parameters, but it's actually applying some of the default integration parameters, and it's trying to do stuff here, right? So that's the difference in doing none as an option and then doing one as like an error percent, okay? So what if we go to where we did our sequence, all right? And so let's see, this one should be, okay, so this is the one we just ran. So now we're looking at the sequence. Now I can just double click. All right, I can see my results. I can see my 4 runs. Now double click, same thing. Okay. So in our case, we're just going to do an area percent for this one. All right, because I just want to show you kind of how these are linked up. All right, so if we do an area percent, what is it going to do? Well, it's going to try to integrate these peaks. All right, so you can see that there's an actual integration that was done, all right, and it did it for all of them. So it links that up with all of them, okay? So what you see over here on the left side is under the methods, it has created a default area percent method now, all right? So out of habit, what I usually do is if this is the first time I'm linking up results and a method, is I go ahead and I try to give this a name, all right? I'm not too keen on long error percent default methods. If it says default in it, I usually don't want to have default, so I go ahead and I try to rename it. So if we go up here, and if we save method as, we will do DP for data player, area percent, error percent. So we'll just do that right here. Okay. All right, save it. All right, so I've got my newly created and saved area percent method, and then I still have the default method listed below it. Okay, so what happens here is if I click on this, area percent default, I can tell that this is still linked up with these result set because I've got the chains next to it. All right, but what I want to link it up with the area percent. So the way I do that is if I click on, and I want to do all of these. If I want to link up individual ones, I can just select the file and link it up, and then link it up by individually. But if I want to link up this whole result set, I can select webinar, the name of the result set, and then I can go down. I can right-click area percent. This is the one I now want to link up. Right-click, link select injections, and it linked them up. All right. this version of software immediately tries to close out the methods that are not linked. So as you can see, I don't have the default method listed down here anymore. So it tries to help clean this, this navigation tree up so that you don't get confused, right? So now I've got a result set that is linked up with my array percent method, and I've got them integrated. Again, these are default integrations, so we'll take a look deeper into the integration here in just a little bit. But each one is linked up now with the array percent. All right. Are there any questions on single injection, loading up single injections or loading up sequence results, or the differences with those?
Thank you, Matt. I have not seen anything come through at this point. I'll just give a quick little announcement here so that folks will have some time to enter any questions. So today's session is the second in the three-part webinar series, and all three sessions are running on a monthly basis right through until April 2018. The next event, so session 3, which is on reporting, is scheduled for November 28th. So we'd encourage you to attend that session as well. Okay, I haven't seen anything new come through here. Mia, do we have anyone that has pressed *1 on their phone?
No, ma'am, no questions.
Thank you. All right, I will continue on from here. All right, and again, we're kind of building on to what we're talking about, right? We did acquisition. We just linked up a processing method with result files. We loaded result sets. We loaded single injection results, and we kind of showed the method prompt, right? So what processing method do we want to do? Are we doing a calibration? Are we just doing an array percent review? So those options are here. All right, so now we're going to take it a step further into the processing method, right? And we're going to look at the actual tree of the processing method, the general tabs, the integration, the compound identification, and the processing layout. All right, so we'll take a look further into each one of these. Instead of just telling you each one on the slide, I'll actually show you in the demo what these options are. All right, so with OpenLAB CDS, you've got two integrators, all right? When you're in a processing method and you go under General Properties, if you go to Global tab, you have ChemStation Integrator, EasyChrome Integrator, all right? Two different ones. And what these are integration parameters that have come from the ChemStation software platform, and then we've got parameters that have come from the EasyChrome Integrator software platform. So the way I kind of look at this is if you come from a ChemStation background, more than likely you're going to use the ChemStation integrator because they're going to be identical. If you come from an EasyChrome integrator background, you're really going to use that because, again, that's identical to the EasyChrome software. If you haven't come from either one of those, then you can kind of choose which one best suits your needs. But we're going to take a look at the difference one of these because they give different calculations. All right, they're different parameters and they're different logarithms and calculations that you use for the integration. So they do give slightly different results. So you do need to be aware that they are different. But we'll take a look at those. Okay, so for this next demo, we're going to load up the sequence result. We're going to create a new array percent report. So we're going to build on the one I just linked to that sequence. All right, we're going to select the integrator. We're going to add comments to the method properties. We'll save the method. We're going to link it to the data set, and then we're going to save all results. All right, so we'll go ahead and dive into simulator. Okay, so we've got my result sets. We've got the array percent method that's loaded with it. So now if I go to the Home tab and we want to go to the method, so again, these, just like with the acquisition, you have different layouts, all right? So we have result layouts that show you injection lists and results, chromatograms, compounds, right? They give peak details, calibration curve, and then you have method. So under method, this is your processing method, all right? So here's the general tab that we just saw. Here's your properties, the exact same as in acquisition. You have a description, the same, I think, 4,500 character length, and then your audit trail if it's activated. And again, that's something to keep in mind is you now have an audit trail for an AOMX and you have an audit trail for a POMX. So you have to understand there's two different locations. There's multiple locations for audit trails, and you have to understand the frame of reference that you're wanting to, the information that you want to gain from the audit trail as to where you go to find those. Okay, so if we go to the Global tab, here's your ChemStation integrator, your EasyChrome integrator, and if I select either one of these, you can see that my integration events, it's right now on ChemStation, that'll automatically change to EasyChrome, right? So you got ChemStation with advanced, and then EasyChrome without advanced. Okay, so if we select ChemStation and we go to standard, these are the standard options that I have for my ChemStation integration, all right? These cannot be removed. I can't deselect to use these. I can't delete these. They have to be there, but I can change the values, and I can change the values to where if I don't want an area reject, I can put 0 to where it doesn't matter, right? So even though you can't delete these, you can actually change the values in order to make them negligible to your chromatogram. So under Windows at the top here, so say I want to look at the chromatogram along with the processing method, I could go and just click on the chromatogram. Now I've got my chromatogram displayed below the processing method. So let's pull up one of these. That's pretty clean. That's clean. Okay, so for this file, say I don't want these shoulders involved. These are, you know, small peaks. I don't want them integrated. It's just noise. I don't want to have them. There's several different ways. I mean, you can go to a height threshold, an area threshold, and I can select these area rejects and height rejects to rule out if I want them integrated or not. In this case, let's do, I usually like to start with slope sensitivity. So if I just do from 1 to, say, 500, I've added in here, nothing has changed, right? So when you make a modification to the process method, you need to go and reprocess all to actually apply this change. So if I reprocess it all, now I'm done, all right? I've got my 2. If I'm okay with this, then I'm okay with it, right? And that's all that needs to be done. If, say, 500 didn't work, it only took 1 out, then I need to make another change. I can change the slope sensitivity to something else and then reprocess all to make those, to apply those to the actual results, right? So if I go through and click each one, these are pretty clean anyways. And the last one, they're not there. These are different too. So just remember, if you make a change in the integration events or table, that you have to reprocess all in order for that to take place. All right. What if I want to add to this? All right. What if for this example, what if I don't want this integrated at 1.44? Right. Say say it's a solvent peak. For this case, it's a very small solvent peak. So say it's just a peak I don't want. Right. So I can go and I can right-click right under my table. I can add integration event. All right, and then I can do, let's see if we go integration. For this, I'll turn it off at 0.01, and then I'll right-click, I'll add a second one, and I'll turn it back on at, let's say, 2 minutes. And that'll be integration, 2 minutes back on. So as you can see, I've got the labels generated, but it still hasn't taken effect. That's because I have to do reprocess all. Right? If I reprocess all, I now have taken effect of the integration changes that I made. The integration is now turned off at the start. It turns back on at 2 minutes, and we're going here. So this is good. You know, especially if you're running GCs and you want to not integrate solvent peaks, this is a good way to just set the time range right after a solvent peak. And so now you're just getting all of your compounds from then on. So if I saved this, all right, these two are added, I can save method, and these two will now be part of the method that I just created, right? So integration events get saved with your method, all right? Just keep that in mind because manual integration is a little different, okay? So I can do that. Now what if I don't want these anymore? I can actually, you know, highlight these, right-click, delete events, and they're back there. These exclamation point pops up because now I've got to reprocess because I removed a change. all right? And so now they're back on their check, all right? So one thing to keep in mind is this pencil that shows up down by the methods. All right, if this pencil is here, that means I've made some sort of change and I haven't saved my method. Okay, so if I just go in and I save method, pencil's done, method's back, we're all good to go. Okay. These check marks mean that they've successfully reprocessed, but it also means that I haven't saved any of my results. All right, so if I closed out of these, if I right-clicked and closed selected injections, what I just did and what I just reprocessed wouldn't have been saved. All right, so if I go in and I save all results, the check marks are done. My link is here because it saved these with my data player error % method, and now we're all set. And so now we have the method linked up, the results are saved, and we've added method properties. So maybe even if you want to go in, get info. So maybe I want to add a description that this is, let's see, webinar area %. Sorry. Come on now. Area %, and we'll say Kim Station because that's what we used here. Then I can go in. I've made a change to my pencils here because I edited, right? And then if I save method, it saves it with that description. Okay, so the one thing I want to point out here, again, is the difference between Kim Station and Easy Chrome. Okay, so the cool thing you can look at here is okay, now we're under Kim Station. If I go to the results layout, right, I've got my injection results. Here is the calculated area 659. So just keep this in your mind, 659.748. All right, that is the area for my first integrated peak. If I go back to my processing method, let me just pull this off here, and I say Easy Chrome, and then I reprocess all, it changes. So it's not a huge change. 656 is not too far from 657, but you do have a change in integration, all right, because these integrator options are slightly different. They're calculated different. They came from two different software backgrounds pretty much. So that is what you need to keep in mind when choosing both integrators. And more likely than not, when a lab starts off with a software and they start off with either or of these, they usually stick to them, right? I usually don't see customers that have some methods with Kim Station integrated and some with Easy Chrome. It's usually a preference of the lab itself or the user that they just want to keep with Kim Station and Easy Chrome. But I did want to point that out, that you do have two differences in both of those. Okay? So with that, are there any questions with loading a sequence result, creating the area % method, integrators, saving method, the difference between Easy Chrome and Kim Station integrators?
Thanks, Matt. Nothing new has come in. I will just give a quick announcement to everyone to give a little bit of time for anyone to enter any questions. So today's session is being recorded, and following the event today, you will receive an email with a link to access the recording of this event. Mia, do we have anyone that has pressed *1 at this time?
No questions, ma'am.
Okay, and Matt, I have not seen anything come through on the Q&A either.
Okay, awesome. All right, so we'll do, we'll just keep going, and we'll just keep going. All right, so we'll review what we just did. Okay, so again, I showed you how to launch data analysis. There's several ways to launch data analysis. Keep in mind about desktop icons when it comes to data analysis. Again, those are project specific. Okay, loading result sets from data selection, creating a new area % method, all right, when you're going in and you're loading result sets that are not tagged onto a processing method, you get the pop-up box to then select, do I want area %, do I want quantitative, do I want MS for mass spec, or do I want none, all right. Then the integrator types, Kim Station versus Easy Chrome. How to save the new method, you get the pencil icon down at the bottom behind the method when a change has been made but it hasn't been saved. And then to link up those result sets and to save all results, all right? So to diving further into integration, all right, when you're in data analysis and you're in your processing method and you're looking at your integration events, by all means, please hit F1 because this will show you, again, this will show you the differences between ChemStation and EasyChrome. So it'll list out the difference, literally the different parameters within each one. So if you're wanting to compare to see what has what, you can use the F1 help for that. It'll also, you can dive into each parameter to see what it is. What is tangent skim? What is the advanced baseline? What are all these options, right? So again, F1 for the help in the software platform is a great tool to use for first-line defense. So integration events. We took a look at this a little bit, all right? But again, these are standard settings that cannot be removed, right? So when you come to ChemStation, you've got 5 of them here. With EasyChrome, I believe there's 3 that are standard that you cannot remove. But you can add onto this, depending on your run, the complexity of what you're trying to achieve when it comes to the integration, and then your values. So you can edit the values of these that you like to change. All right. There's also, when you select ChemStation Integrator, there's an Advanced tab below Standard, right? So if you go to Advanced, you then have more options that are about the tangent skim. Which mode would you like to choose here? The peak telling, peak fronting. How do you want to set the skim valley ratio? So you have a lot of these advanced parameters that are under the Advanced tab for ChemStation if you'd like to do this. And again, if you're at this point, hit F1 and you'll go to information on tangent skim, on skim valley ratios. What exactly is being calculated here? How are these being solved? How can I use this for my runs? I know I keep repeating it, but again, F1 is very nice. All right. So then there's manual integration. Okay, so sometimes these integration events don't get you 100% where you want to go with some of your peaks. All right. So you can manually integrate to modify an integration or integrate a peak specific to a data result that your integration events are not capturing. So the thing to keep in mind about manual integration is manual integrations are saved to the result file itself. All right. Integration events are part of the processing method, so those get saved with a processing method. But manual integration is specific to a data file. Okay. So if I'm in the results layout and I'm looking at the chromatogram, you know, you've got a couple peaks that are integrated. All right. The way that manual integration does, and we'll see this in a second when we go through the demo, is the pointer is interactive, all right? There's ways that in the chromatogram that there's a tool option that's outlined in red. If you select the tool option, you go to manual integration, and you have just a list of options and tools that are going to be integrated into what your mouse does, right? So you basically have to activate your mouse to do chromatogram integration, and then once it's activated, you then have a ton of options that you can do for the integration. Create new baseline, move the baseline, split a peak at this valley. The software tries to solve what you want to do based on where your mouse is on the peak or on the baseline, and then it gives these options. So we'll see this here in a little bit more. But if there's too many options, which for some cases there can be, you can decheck these so that they're not part of the interactive mouse or pointer on your chromatogram. All right, so with this, you've got a couple terms that are involved in the mouse pointer. You have an attractor, right? So the attractor is usually used if you want to create a new baseline, or if you want to shift it around. Then you have an intelligent cursor, which is, according to this picture, they're basically shifting. They've done they've split 2 peaks based on the valley. And if I pull the mouse over, I know you can barely see it with a slide set, but if you hold the mouse over the split line, it then becomes interactive with 2 arrows that you can move it left or right, right? So that's the intelligent cursor. And then the really cool thing is the integration wheel. So if I'm trying to change something that's already been integrated, extend the integration line, retract it a little bit, I have a wheel that's going to show me I'm moving left or right, right? I'm moving up or down, or I'm creating a new baseline. So we'll take a look at these further into the demo. All right. Okay, so with this slide, we're seeing that you have to toggle into the manual integration to activate your pointer, right? So you're giving your mouse the functionality to do the manual integration. So all you have to do is select, when you're in your chromatograph, if you select this icon with a finger, what that does is my mouse now changes from a pointer to either the integration wheel or the double line in order to really kind of determine what you want to do with these peaks, right? So if I'm selected with the finger on the manual integration, you can also see that I've got these red tick marks that are displayed on the chromatogram. When I'm not in manual integration, those are not there. I can only see the black integration line. But when you're in manual integration, you can actually see the start-stop tick marks that are on that integration line. Okay. There's also a way to save manual events to your processing method. Not many people are using that, but you do have that functionality to do that. So basically, if there's a peak, an unknown, for example, that's shown up in one of my result sets, and I then have manually integrated that small unknown that my integration events are not coming up with, and I have this feeling that this unknown may keep popping up sometime in the future, I can put that integration line that I manually integrated that unknown and select the folder, this folder here, and that'll take it over to the processing method. Okay. Okay, so there's indicators for what has manually been done. Okay, so here we're looking at data processing. You got a result set, and the final run was manually integrated. All right, so when something's manually integrated, you've got an asterisk that shows up in the name, and then at the same time, you have an asterisk on the number for the retention time above the peak. Okay, and so both of these are indicators that that it's been manually modified. All right. There's no way to remove these indicators. All right, they're absolutely going to be there if something's been manually changed. And this kind of goes back to some of the compliance and regulatory aspect of the software. So there are indications that something is manually done, and these two indicators are some of the main indicators that show this. Okay, so what we'll do now is we're going to load up a set. We're going to keep working with our existing data. All right, we're going to switch to the results layout. We're going to manually integrate. All right, we're going to show you how to put that into the integration events, and then we're going to save and reprocess all results. So, okay, so if we go to the results layout, all right, so I have a results layout. Say I don't want the processing method as part of my results layout. I can go to reset. If I hit that, then it changes the layout back to the default layout. Okay, so let's find one. Okay, so let me modify this really quickly, just so I can do a manual integration. So what I'm going to do is I'm going to actually add on what we just did earlier, and say I'm going to turn my integration off, and then turn it back on at 2 minutes. Okay, let's save that method. All right, let's reprocess all. Okay, and now we'll go back to the results. So, say for example, I want this small one to be integrated. This very small peak. This is an unknown that has shown up in one file, right? It's not in any other ones, but it's shown up in one, and I just want that manually integrated. So I can zoom in, right, get it kind of close. All right, so the first thing you have to do is you have to activate your pointer. So here is my manual integration pointer. And again, if you forget what some of these icons are, you can just hover over it, and we've got information of what they do. So if I activate it, immediately I've got this interactive mouse, all right? So, and it knows that there's no baseline here, so it assumes I want to do a new baseline, all right? So right now, if I can click, then I can just kind of go over and say maybe my end peak is going to be right here. Okay, so now I've integrated that smaller peak. It just populated in my result set, or in my injection results, and so now it's been integrated. Okay. So here's the interactive will. So when I highlight over the end of it, it assumes I want to modify this integration event that's already been established, right? So I can take it and I can move it. I can shift it back. I can end it up here if I need to. So that's the interactive will. All right. So let me zoom out and look at. Okay. So let's actually look. I'm going to zoom in on these two. Okay. So maybe I want to. Maybe I don't want that to actually increase right here. Maybe I want to actually extend it down and actually have the baseline come down, right? I can actually move these base points down, and I can have it like this where I try to follow the baseline as far as I can, right? So overall, it shows you, it tries to help you do what you need to do, right? It tries to interact and assume that where you're at, either on a peak or a baseline, that this may be what you want to do. So for this example, we've got it, I'm coming up on the shoulder of a peak. And so this is a good way that if you've got a peak coming out on the shoulder of, say, a solvent or on the shoulder of an internal standard, I can go towards that shoulder and just pretend like there's something big here. I can click there, and so it's split it up. So that's how you can easily split peaks as well, right? Okay, so if I zoom out, all right, the indicators are, I now, let me deselect this. All right, I now manually integrated this first one because I have an asterisk on the first one, and I now manually integrated these two because they now have asterisks, and this file itself was integrated. All right, so that is, that's the indication of what's been integrated, and that's what you can easily see. Okay, so if I go back in here, I now can see copy the integration to the process method. So if I click that and I go to my processing method, all right, down below where we just saw the integration events, we have manual integration. And so now those events are here, all right? They're added in, and so now they're going to be saved with that processing method. So in this case, let's say I save the method, saves them all in there. I reprocess all. The thing that you have to be aware of now is I have manually modified all of them. And how is that? Well, I saved manual integration into my processing method. So that's something to keep in mind when you add manual integrations to a processing method. The software is now going to ping all of these to have been manually modified. All right. So that's, again, if you can save a manual integration to the processing method, but it's going to indicate it that when you reprocess with everything, it's going to show up and show that. So what I can do is I can kind of go through here. I can right click and I can delete all signals. This will delete everything. Yes. I can then save the method, reprocess all, and now I don't have the manual things onto what I've done there. Okay. All right, so with that, are there any questions on manual? Well, before this, let me show you. Again, you have to deselect the mouse, right? So when I'm done manually integrating, you just need to remember to go back and deactivate the manual integration. All right, and so now you can go on and work through and zoom in, zoom out, do what you need to do with the standard chromatogram that you would otherwise. Okay, are there any questions on this?
Thanks again, Matt. No new questions have popped through here on the Q&A box. Mia, do we have anyone with a question over the phone?
No, ma'am.
Okay, awesome. So we'll keep on trucking along. All right. All right, so again, we looked at the two integrators, EasyChrome, ChemStation. This past session, we talked about the manual integration, the interactive, how it's interactive with the mouse. You have to turn it on and turn it off. Don't forget to turn it off because sometimes you think you're zooming in and out around a peak, and then all of a sudden you change the integration, so then you got to delete what you just did, reprocess. So make sure you turn it off, all right? And then the indicators are there. So remember, if you add, if you save manual integration to your processing method, and then reprocess, everything gets tagged as it is manually changed, okay? So compound identification. The cool thing with compound identification, unlike some of the past softwares, is you don't have to deal with a calibration table, all right? It's interactive with the mouse. As long as you have the peaks integrated, then I can just literally select a peak and then add it to the compound table, all right? So for this one, you're in the method layout, all right? We're showing you the compound table, which is down below the integration section that we just worked on, and this is just a list of peaks that were added. All right, so you can literally right-click on a peak, again, that's integrated, and then you can add it or you can add multiple compounds. So we're going to see both of those and how they work there. So we're going to keep working with the existing data. All right, we're going to look at the method layout. We're going to identify peaks. We're going to name those peaks, all right, and we're going to add them to the table. We're going to do individual peaks, and we're also going to do multiple peaks together. I want to show you how to do those together. So we've got our method layout, all right? All right, so we go down the compound. Here's our compound table. It's empty, all right? So say, for example, in this result set, I've got 3 calibration levels. I've got level 1, level 2, level 3, and a sample. So if I go to my standard run, I've got 2 really solid, clean runs here. So these are the 2 peaks that I'd like to add. Okay, so again, assuming that they're integrated, I can just highlight the peak. I can do either one, right? And I can do them individually. So if I highlight, say, the first one, I right-click, add peak to compound to method. All right, once I do that, it gets populated in the compound table. What I'd like to show you is you can do multiple ones. So if I hold down Control, that first one's highlighted, I go and highlight the second one, then I can right-click, and I can add multiple, and both of them get populated into the compound table. All right, so by default, the retention times are their names, right? But I can immediately go in and change the name here. So I can do, I don't know, chocolate and caramel. We'll have some tasty peaks here then. So we add these. So now we've just immediately, we've added names and we've identified compounds without even having to deal with a calibration table, all right? So if we reprocess all right, I can go through each one of these, and now I've got both peaks, chocolate and caramel, both labeled through all of them, and then here's my sample. They're the 2 that are named, okay? So they're both named, and they're ready to go. So with this compound table, this is also where you can change some of your retention time windows. So if you're doing if we scroll past, you can change it based on the minute. Say, I mean, this is kind of a tight window, but tight windows are usually better than larger windows. They mean that your run's more equilibrated or consistent. So if you want to extend your window out, I can say from, I don't know, 1 minute to 5 minutes, and immediately it takes up, I mean, that's way too large. I mean, here's, yeah, it's larger than, let's take it a little bit smaller. Let's do it at 1.5. Okay, so now my window takes up only a huge chunk of my run instead of just a small amount. So if this peak falls anywhere in this window, it gets identified, right? So that's part of doing it based on minutes. Or I can also do, let's go to 0. I can also do it based on percent. So if I don't want it at 1%, I can do 10%, and it goes on to a percent left and right of the peak, right? So those are how you can change some of the windows. All right, and then you also have a retention time window. This is where you can update after each run if you'd like, or after the calibration standard. So these are, this can also be reflected into the sequence table as to what you would like to do with your retention time and your retention time update. Okay. All right, are there any questions identifying peaks and selecting peaks to be in the compound table?
Okay, I still have not seen anything new come through our Q&A box here. Let's check the phone. Mia, do we have anyone with a question over the phone?
No questions, ma'am.
Okay, I think what we'll do is, this would be a good spot to just take like a quick 5-minute break. We're about 20 past the hour now, so we'll take a quick 5-minute break, and then we will continue from there. And yeah.
Thanks, Matt. And certainly if anyone has any questions while we're taking our break, please feel free to enter them into the Q&A box.
You're live. Please proceed.
Thank you. All right, so we are back. All right, so just to review what we did before the break. So we did the interactive manual integration, the differences of what the mouse pointer does, right? It changes functionality based on where you're at on the baseline, if you're on the shoulder of a peak, where you're at in the chromatogram as to what you would like it to do. And again, it tries to help do what you want it to do. So it assumes that, okay, I'm between two peaks, I'm down in the valley, maybe I want to split these. So again, that's the brains behind the manual integration. All right. Then we showed how to identify peaks, okay, the easy way to add peaks to a compound table. Do we want to do a single peak or did we want to do multiple peaks? So you can, what I did was I did control and just clicked through the peaks. And so if you hold down control button and just click through the peaks you want to add, you can do that. You can also do shift. So if there's like 20 peaks and I click one, that comes out at like 3 minutes. I can hold down shift and then click one at 12 minutes and everything in between gets populated into the compound table. So control button and shift button both work when adding peaks. Once you add it, we added the name, easy name to add. We don't have to deal with a calibration curve or have to build a table to actually do this. You can just add the name, reprocess, and it shows up in your other results. All right. And again, like the last note here says, remember to deactivate manual integration. The only reason why I say that is you can go through, you're trying to zoom in or out around a peak, and then all of a sudden you've changed the baseline of the peak. Then you have to go back, and the way you get around that is I closed out the data, reload the data from the data selection tree, and then go back to doing what I need to do. So, okay, so calibration. Again, F1 is a great functionality, right? It's your first source of information. It gives you information on calibration curves, the calculations, how to do external standard, internal standard. So again, help and learning is very, very useful. Okay, so when we're in data analysis, it requires the quantitative processing method to be selected. So again, just like we saw in area percent report, calibration wasn't labeled here, all right? You have to actually go down and do either a quantitative or 3D quantitative or mass spec to actually get this calibration option in there, all right? And what happens is when you do an area percent, when we look at compounds, our compound, we could only see identification. We didn't have a calibration option. So now when we go to quantitative and you pick the quantitative method, then you can create method. Then now you have the calibration option, and now you can do internal standard, external standards. And so we'll look at the options now from the calibration tab, right, and so what we can do and how we can build this, all right? So just due to time, we're really only going to talk about the external standard, the ESTD standards. Internal standards are very similar to external standards, all right? Basically, the idea with an internal standard is you have a list of identified compounds. You assign one of those or more, whatever your internal standard is, and then you have to reference the other compounds to those standards. So that's kind of the idea of the internal standard. But we're mainly going to address the external standard here. So what we're going to do is we're going to load some runs that we have that we've already done. All right. I'm going to go ahead and load up the existing runs, and I'm going to create a new method because I did one with an error percent, but now I want to do one with quantitation so I can do a calibration table. We'll build the calibration table. We'll set some amounts. We've got our 2 peaks. We'll update the master method, so we'll talk a little bit more about the master method and how that's coming into play. Then we're going to check for our injection list because there's a point in this that you have to remember. You have to go back to your injection list to modify if it's not correct in your sequence. So we'll show you that as well as we walk through here. So, okay. So what I'm going to do is I'm just going to close out. Was selected. Save. I'm going to reload these runs. All right. Again, I have an error percent. I don't want to use that because we have to have the calibration table, right? So under compounds, I've only got identification. And again, this is because I've got an error percent report, all right? So what we can do is we just have to open up a new report, all right? We have to open up a new method. So if we go to new method. I'm not trying to open one. I just want to create a new method, and I want it to be quantitative so that I can calibrate, all right? So we'll create that method, all right? Again, we now have to link it. I have a new method once. I'm going to go ahead and save this method as something else. So we're going to say, we'll do STD, all right? The calibration for there so that I know what's going on. Okay, so the next step is I have to link it. So again, right now it's still linked up to the area processing method, so I need to go to my results, right-click, link, and now we're linked. Okay, so the one thing that happens here is obviously I've got a brand new method. So what happened to my compounds, right? So they lost with the error percent method, and I mean that will happen. So basically, I just need to add these in again. So we'll go back. Right-click, add multiple peaks. All right, so we got our peaks in. Because again, when you reach to the point of where you're trying to create a calibration curve, you have to have your peaks integrated. All right, that's your first step. Then you have to have them in the compound table. They have to be identified, and then you can take those identified peaks. So if we go down to calibration, they are now part of my calibration table, and those identified peaks are going to be what I'm going to base it off of, right? So now that we're in the calibration table, we can see, okay, I can add amounts, units, and concentration units. So what these are indicators. These have nothing to do with the calculation. So I can add, I'm just going to do milligrams per liter, and I'm doing it for both just because, I don't know, I like them to be filled out. I'm not someone that likes blank spaces, so I'm going to fill out both of them. And again, these are just indicators. They're not affecting the calculation of amount or concentration. They're just an indicator, all right? So I can keep going past. I now have my response options, and these are drop down. So I can say, am I doing area? Do I want to do it based on height or percentages? All right, then I've got weighted methods. So I can do amount squared, or based on response, right? So we'll keep going down the compound table. All right, now we get to some of the calculations and some of the basic parameters of a calibration table. So for here, you got your curves. Do you want it linear, quadratic, average, RF, exponential? These are your options that you want to do. So for example, I haven't even done this yet. So let me do this and type in F1 and to see where it brings me. Okay, so now we're in our help. We're doing compound calibration. So now, what all is it giving it? It's literally listing everything out on the table and what all means. So what does RF definition mean? Well, it's a response per amount or amount per response. What does normalized to mean? What does concentration calculation mean? So you just have a ton of information as you're going through here as to what it is, and it's context specific. So it's specific to where, to the window I'm working in and to what I'm doing. All right. So if we keep going down, you got origin. This is, especially if it's a one, we have a 3-level calibration here. I've got three runs in a sample. If you've got one level, then usually if you're trying to create a table off of one level, then you have to utilize 0, right? So then you can have to force it to 0, include 0. So these are your origin calculations here. For me, I've got 3 levels. So I'm gonna usually include. You can include or ignore 0, right? So you can do either one of those. Then the multipliers, and then now I've got my 5 levels. All right. So just like I just mentioned, I've got 3-level calibration. So what do? I don't need all 5, right? So that brings us over to the general tab behind the compound table. So if I go to general, this is where you can specify if it's external standard or internal standard calibration table, all right? So you can just click either one of these. And what happens is if I select internal standard, my compound table changes, right? And I now have what is the internal standard, what is the amount, right? As opposed to if I go back to external standard, it's different, right? So this general affects what my calibration table looks like, okay? And then now I have the number of levels. I don't need 5, I want 3. So I'm going to modify that. And then you have your curve calculations, your RF definitions, and then your concentration calculations you can modify here. So if I go to 3, That immediately changes the table back to 3 levels. All right? And so now I can add all 3. And I think for our example, we're doing 100. We're going to do, let's see, 250. And then we're going to do 500 as the top level. Okay, so we've identified the peaks. We've put them into the compound table. We've modified the levels. We've indicated that this is an external standard. All right. So what? Let's just reprocess and see what happens. Right. Let's see if this is all that I need to do. No, it's not all that I need to do. Right. We get a warning here. What happens is the curves are not found. Right. This is telling you that curves are not found. So there's a big step in how I acquired my data that is preventing this from going on, right? So what I need to do now is I need to go to my injection results, my injection list. Okay, so let me just keep trying to clear this up. All right, so in my injection list, when I acquired these runs and I ran this sequence, I had them all with a sample type of sample. I didn't indicate any of them were calibration runs. So I need to now go and change these to calibration standards on my injection list. All right, I can change my levels. Okay, and so now I've updated my runs. Now it knows that the injection list, I have 3 calibration runs and a sample, and then we have a run type. All right, so this run type, this is where you do your averaging or replacing. All right, so you have 2 options here. Well, you have 3 because you can leave it blank. If I leave this blank, it averages in these results with previous results, right? So you're averaging in your calibration curve, right? If I go in and I say clear all calibration, then what it's doing is it's removing the historical calibration points and then saying this is my first curve, my sample is going to be calculated against this curve, and that's it, right? Then you can have it clear calibration at level, and what this means is it just clears it at the 1 level side, right? So the one thing to keep in mind about the run type is you can do fill down. Like I can right click and I can fill down and I can fill down everything that's in the sample type. Let me tell you this about the sample. But you don't have to have a run type for every run, right? So when I do clear calibration, this kind of goes back to how you're setting up either an SOP or how maybe you've done this in the past with other software. Are you clearing calibrations, every morning? Are you clearing calibrations for each sequence? Are you clearing it every month? Do you never clear it? It kind of goes back to what kind of your practices within your lab as to if you're clearing up your calibration curve, right? So, so now we've got our table. We've set our injection list, clear all calibration. So we have the pencil here, so let's just go ahead and save the method. All right, let's reprocess all and see what we get. All right, so if we go back to chromatogram, let's see here. Go to compounds. Okay, so when we're in compounds, and we go to the compound layout, we can now see our calibration curve that we just created. All right, and we've got it based on our chocolate peak and caramel peak, right? And it shows you on the curve where they're falling from these 2 runs, right? So if I go through, I get quantified here. Let's see. Here's the 2nd level, 3rd, and then we've got it with our samples, right? So for each one of these runs, you have the calibration curve builds on itself, right? So here's your 3rd one. You've got 3 plots of information, 3 plots of data. So this is how you can this is how the software works and allowing you to clear at level, right? So if I want to clear at a level, I'm only clearing out 1 calibration level and not all 3. So you have functionality for all individual ones, right? So now I've got it shown up here. Again, my 3 chocolates shown up there and caramel. All right. So Any questions at all about the external standard table? I know it seems it may have looked like a lot to do, but let me just say this real fast. The idea is you integrate, you identify your compounds. In this case, I've got 2. Once I identify them, they get populated into a compound table. Then you assign what your levels are. All right, so I can scroll down. I can assign the amounts of my level. All right, and then the big thing that a lot of people forget is that you have to make sure your injection list is correct. Now, if I had submitted a sequence, and in my sequence I called these cal standards, then my injection list would be correct with the calibration standards. But when I submitted the sequence, I had them all listed as sample. So that's why you have to go back into your injection list and then specify the sample type of what they are. And that's where some people kind of get thrown out when they're doing these calibration curves. So any questions at all so far about the calibration table?
Thanks, Matt. No new questions at this time. Mia, any questions over the phone?
No questions, ma'am.
Okay. All right. So we will let's get the right toolbar. Okay. Okay. This actually brings up one more point about the master method. No, almost forgot. Okay. So with calibration curves, this is when this is when master methods kind of come into play a little bit more. The idea is when you're working with your result set, and say, for example, I'm working with this web calibration ESTD method, this is technically, this is my result set method. All right, so if I highlight over it, it comes down at the bottom of the screen as the folder location. So this is literally just within my result set. All right. So if I go and I want to run runs and submit sequences, I either, one, have to update the master method, or I have to, when I submit the sequence, go back to result set to find this method. So I renamed this web calibration ESTD, so I don't have a master method with this name. So what I need to do is if I go and update master method, are you sure you want to replace the master method? So what is happening is, since I created a processing method and I named it this web calibration ESTD, and there's no existing method called that, right? This message is pretty much saying we're updating a master method, but all this is creating a copy of the web calibration external standard into my methods folder. All right, so that now I now will have this in my methods folder, and if I hit yes, then I have updated my master method. So now I should have web calibration ESTD listed in my methods folder and not result folder. All right, so we'll take a look one more time at the master method towards the end of this, just to kind of hone in on what's going on there. All right, so what do? You had to pick the right quantitative processing method, all right? So error percent will not allow calibration, so you have to make sure that you're prepared to do the calibration method, all right? Adding a new calibration section under the compounds, right? So when you do select a quantitative processing method option, that then allows the calibration tab, all right? Your injection list must have the correct settings, right? So what we did was we did that at the end. When we assigned, we put the compounds in the compound table. We looked at the calibration. We added the calibration amounts, and then we went back to the injection list, and then we had the correct settings for the run type. All right. The compound layout is easiest. So if you're looking at the chromatogram and your injection results, that's easiest when looking for some of the calibrated details. All right. So that's just kind of a tip on one of the layouts. All right, and then your injection results, it's going to show your amounts. There's no need to go and generate a specific report. There's no need to print anything out. You're going to have real-time amounts after you reprocess displayed there on your screen. So you don't have to you don't have to actually print out an actual physical report to get this. So this brings us into reporting. All right. There's several report options that are available. There's several templates that are available with the software, so you don't have to start from scratch. You don't have to edit if you don't want to edit, but you also can. And that kind of brings us to the third session which is IR reporting, which covers detailed editing of these templates and also briefly touches on some of the custom calculations that can be added in this intelligent reporter. So the intelligent reporter is amazing. It's a great thing that for example, you can take a template, you can change the logo on it so it doesn't say Agilent, but it says your own company's name on there. So you've got it. You can really do whatever you'd like to do with these report templates when it comes to IR. Right. But just for the sake of time, again, we're just going to generate an error percent and an external standard report. The intelligent reporter really goes over, is really tackled in session 3, which I highly recommend registering for and kind of participate in that just to learn more about the intelligent reporter. All right, so in reporting, in this view here, we're looking at the data processing. All right, we're in our processing method, and at the very end of the list of what we can do, at the very bottom you have injection report. All right, so what happens is your processing method is linked up to the report template file, the RDL file, right? And you can link up more than one. So as you can see here, I can have one linked up, sent to a certain location that we'll talk about in a second, and then I can have a second one that's sent either to a different one or it's just different information. So I can have more than one report template tethered onto a processing method. All right, and then over to the left we have the reporting section that's below the data processing. So previously we've seen data selection on how to select these runs, and then in data processing how to really the core of data analysis basically. And then below that you've got reporting where you can do preview reports, you can edit these reports, and you can change the templates out based on what you need to do. All right, so printing these reports. So there's one setting that's in the project level, right? So this picture on the left side is showing you the list of your projects, all right? You've got, just the list of the projects that are created. And then if you go into the CDS settings, you have a project options, which says to allow printing of unsafe process methods and results. By default, this is not selected, all right? Because if you think about it, there's really if I'm allowed to print unsaved results, then that becomes a regulatory and compliance issue. So that's why by default it's not selected. But you can select it. So if you're in an R&D environment, if you're in academia, that you really just need to, I need to print out whatever I process, no matter what if it's saved or not, right? I'm just trying stuff out. You can check that box, and then you can print whatever you need to print without having to save. But if it's deselected and I go and I print results, it's going to ask you and say, do you want to save results? So it's going to have a pop-up box before it actually prints out. All right, so when you're in data analysis, you have two options where I can print all or I can view the PDF. So we'll take a look at both of these and the differences for them within data analysis. Okay, so it's important to know that you can do automatic printing, right? You can do automatic printing, but it's specific to single injection reports only, right? So if I submit a sequence, right, a 7-line sequence, and in my processing method I've got, say for example, short area report. Short area is a single injection report. So as soon as those 7 runs get acquired, it can send it to a printer, and the printer's already printing those out in real time, right? And I don't have to go in, I don't have to do anything with the software except hit run and run the sequence. But other reports such as sequence summary, cross-sequence summary, library searches for mass spec, all of those are done manually. They're not automatically produced once the data is acquired. All right. So what we're going to do is we're going to keep going with this data set. All right. We're going to look at the reporting. We're going to see what there's. You may have to go in and refresh the preview every now and then to actually make sure your real-time data and information is displayed. Save the results. I'm going to show you how to send it to a file system, all right, to a file location. And they're going to reprocess and then show how to import default templates, all right? Okay. So we're in the calibration external standard method, all right? So we go all the way down to the bottom. And you've got your injection report. So I'm just going to close out injection list to create more room. All right, so now I can select which report. So for our example, let's do, we're just going to do a short external standard. All right. By default, it's got none as a destination. But say for an example that I see a lot with customers recently is people want one folder on their PC that only has reports. They don't want to go through data files. They don't want to go through anything like that. They just want to go to their desktop, PDF reports. Here's a list of my PDF reports. So this is how you can send a PDF report, Excel. You can do plain text, Word document, several different options to a specific location that kind of prevents you from having to look through all of your data results. All right. So if you go to the file, the report destination is a file, is an actual file. It's going to be a PDF. By default, it's on none. But what we're going to do is we're going to select the Windows file system. All right. And all the Windows file system is just the local file that you have. Right here, we're in the C directory. I've already got one. PDF report files. This is just a folder that's created that only houses PDF files. All right. So now I can also do the second report. So I can do. So for this example, we want to do. Let's do short area. We're going to do file PDF. We'll do Windows file system. I'm going to do the same PDF report files, same location. All right. So the big difference here is what storage is if you have a content manager on the system, that is where you're going to send that, right? So you're going to select storage and have it sent to the content manager so that your report is displayed within the content manager, right? And so if you hit storage, it's just going to browse. Let's see. It's just going to browse where the storage is. I don't have the storage here, so it's still just in the C directory. But yeah, the Windows file systems, let me go back to PDF report files. Okay. So now I've got two reports, a short external standard and a short area report going into report files data. So the locations, let me actually go to that folder location. So in my C drive, let's see, where am I at? PDF report files. Yes, I've got some from earlier, so I'm just going to delete these just to kind of clean up this location. All right, so that's just a basic location out in my C drive. So now I can just save method. All right, so now my method is saved with two different report templates tagged onto it. Okay. So now if I reprocess, then I can save all results. Okay. Well, so we got one with this file. We'll ignore that for right now, but it's because the retention time window of the first one is not finding one of the peaks. But what we'll do is show you now that if I go through, actually let me close out this one run. Yes, and don't save. Come on. Sorry, let me pull up this method again. So it pull up that method. Let me do it with, let me just do it with the error percent now, since I know that this actually works with all the runs. Since I didn't save it, let me go ahead and add real quickly the two files. All right, short external standard, file PDF, and then the location, report files. And then we're going to add the second one, which is the short area. And then that location as well. All right. So now I will save that. So now, again, we're working with the error percent just because of the calibration issue I was running with the other one. We'll do that. We will reprocess all of them. And then we will save all results. All right. So again, I've got to save results in order to print. So now I can print all. All right. So now it's going to go through and it's going to print out 4 of them. There we go. Okay, so if I go through, I can view PDFs, and I can look in that folder. Well, I can look at the PDFs that are in my results set folder, or I can go through where I sent them, right? So I showed you guys how to add the second location. So if I go through PDF report files, here are my files, all right? I've got 1 and 2 for each run. So all the 1s are external standards, and all the 2s are the area percent. So if I go through an external standard of, say, I can double-click here, and now I can actually see a single injection report. This is for my sample, and then you have your single injection report, right? So again, I removed the calibration table, so that's why it's not displayed there. But if I go to the area percent, hold on. Let me get back in here. There we go. Now they're loading up. They're all loading up. Okay, so now I've got area percent, and so now I've got information on each one of these, right? So if I go through, and let me close all these, and we're going to go back and identify these two, because again, remember I'm doing this back with the area percent. All right, so now if I reprocess all right, save our results, then print all again. Okay, now I'm going to have area percents with those identified peaks. Okay, the 2 that I added here. So now we're going down through. We've got. And so here's my 2 peaks. I don't have amounts of concentration, again, because I changed methods and I'm not showing it with the calibration run. But then we have 2 and the area percent. All right, so now you have both of my identified peaks that are displayed with my area percent report. Okay. All right, and so what this is doing, so if I'm in my data analysis and I view PDF, it's going to view the PDF that are within the results. So what's happening is when I tag on, right, when I assign these report files to a run, even if I hit none, I am getting a PDF in my results file, right? So if I want to see it, the results file, so now I've got 2 locations because we added the second location on the reports file. So that's why the view PDF is looking at my results folder, and it's not looking at, let me go back to the second location. All right. So that's how you're having 2 locations for your templates. So the question I have is, what happens if I go in and say you're building your process method, you've integrated, you've added your compounds, and you go in to apply a template, and I hit this drop-down box and nothing shows up. What happens? What do I do? What that means is you've got to go and you have to import the templates. So when you create a project in the control panel, each time you create a project, you have to import these templates. So I've got one here that's designated no templates loaded, so I'm going to start that. So this just kind of shows you, and while that's loading, I'm going to show you in the down below data processing, we have the reporting screen. This is how you can also go through and preview real-time what's going on. So if I have a short area, I can double-click short area, and I can look at the report preview in real time without having to print anything out. Right, so I can look down, here's my 2 peaks, so I can go through and I can select on this second run. Here's where I have to hit refresh preview, and then it's now information from my Cal 2, my second run, and then I can do it for 3 here. Or I can select the entire result set, hit refresh preview, and I should have 4 pages. Yeah, so I've got 4 pages, and now I'm showing all of them, and I didn't have to print anything out. I didn't have to send anything to a printer. I'm previewing the report in real time. So it's a very good way to get information from your runs that you just acquired without having to use paper, send stuff to a printer, or send stuff to other file locations if you just want it right here on the screen. So if we go back to the no templates, so this is, again, my project that I don't have any templates loaded. They're empty. So if I go back to data processing and I go to my, well, I don't have one loaded, but if I went to my processing method and I went down to my report template, that would be empty, just like this report templates. All right, so how do you import these? All right, because each time you create a project, you're going to have to do this. All right, so we're in data analysis. Under data selection, you go up to import export. All right, and once you're here, you've got report templates. So if I just select import default report templates, I can do A4 letter. We're just going to do letter. I can do OK. Once it's done with that, it'll tell me I've imported a certain number. I've imported 30 templates. All right, so now we go back to reporting, and I've got those 30 templates here. All right, they're all ready to go, short area, ready to go. So that's something you have to keep in mind if you're generating projects. You have to import your templates. And projects are generated, seldomly generated, right? Once you establish projects and instruments under projects, you're not necessarily generating projects very often. So this is a step that oftentimes gets looked over and doesn't realize these to happen until you're actually like, where are all my templates? I'm creating this process and method and I have no templates. So that's one reason why I want to point that out to make sure you're aware of that. So with that, with reporting, are there any questions up to this point?
Thanks, Matt. No new questions at this time. Mia, do we have anyone over the phone?
No questions.
Okay. So with that, we took a look at the report preview. We saw the sample injection, area percent, and external standard, how to link up two of them. And a really big thing here is to show how to import the default templates to the project. All right. So with all of this, we've taken the very beginning of acquisition, and we've kind of run through the whole process. But to kind of wrap all of this up and to kind of pull it all together, what I want to show you is doing the complete run, right? So now we've reached a level where when we submit a sequence, I can have an acquisition method and I can have a processing method all included in that sequence to where it's all done automatically, right? And the big thing here is that if I submit a sequence and I have an acquisition method and a processing method included, that data set will be linked together, right? I don't have to go in. I don't have to worry about the pop-up box that's saying, is this an area percent? Is this an ILMS, a GCLC 3D? I don't have to worry about those options. It's already linked up and it's ready to go. All right, so again, the complete run, right? The single injection and sequence run. You can have the AMX file and processing file all combined in there to run and to link and to process all together, and then to submit reports all together, right? So you start with integration, compounds, calibration, and printing. So this is kind of to pull it all in together, right? So what we're going to do is we're going to set up a sequence. We're going to add an AMX and a PMX file, an acquisition and a processing file. We're going to run the sequence, and then we're going to review and see what it actually shows and the difference between what we've done before, where we have to actually go in and select which method we want to use or which processing type we want to use. So if we go into sequence, and again, I'm in my data player. This again takes runs down and makes them really quickly, so it's good for simple time. So I'm going to exit that view. Again, we're going to take it. I'm just going to take it from what we did earlier. All right. So now I got my sequence template. All right. We've created the process method, so now I can go in and I can actually use what the process method we've done. So the area percent method, I can actually go in, add that process method. I can fill down, and now we can do everything with that processing method, right? So with this area percent method, remember I have a short area and an external standard. The short area is a single injection report. So if I had that connected to a printer, it would automatically print after each one of these runs, right? So I would have 4 pieces of paper at the very end that would be short area, okay? So that's how the automatic printing works for those single injection types. So this is also where, okay, I've got 3 calibrated runs. All right, change my calibration standards. I can change my levels. All right, and then I can do clear all calibration. And then you have these options. So more specifically, let's go back to our calibration run, right? So then we actually utilize the calibration curve that we built into it. What we're saying is I want to clear all, right? And we're going to have 3 levels. So now I can do webinar. Let's see. We'll just call it workflow so I know which one, and then give it a timestamp. Okay. So now we've got everything done. We're doing an acquisition with an acquisition method and a processing method. It's all going to be done together, right? So there's no more having to redo stuff. If in my processing method, again, if I have a short area report, it will take that immediately and send it over to the printer. If I'm doing a sequence or cross-sequence report, I have to manually do it through data analysis. All right. So as we're looking through this, you can kind of see that it's automatically pulling some data through. All right. And this is how the data player works. It just takes longer runs, shortens them down, but actually simulates that they're longer runs. Right. So now I've got my 2 levels, so I can kind of shrink that up a little bit to see there's my level 2. And then my level 3 will come out here in a second. There's my level 3. And again, the online signals, it normalizes based on run. So that's kind of why it's acting a little goofy. When I'm shrinking it, since these are such quick runs, it's actually normalizing right on the fly. So there's my 4th one. All right, so then we're good there. So if I go to web session, we'll go back, and we're going to go ahead and close this. So let me do data processor. We're going to close out this result. All right, because I know that's a good habit to try to keep, is to close out runs that you're not using and to just to kind of keep your work area clean when it comes to the injection tree. So this was already loaded, so I need to hit refresh. All right, once refresh here, here's my new run. All right, there's my new injection list. So if I load it up, I should have, everything should be done. I've got the information here. All right, so if I go through and look at my compounds, I've got my calibration curve all ready to go. It's all assigned, all done. Each of these runs are all, the peaks have been identified, the amounts have been identified, and they're added onto here, added onto the curve, and everything is done and ready to go. So the other thing, and then now, we can hit print all, so that all the reports are done. If we go through see again, all right. Well, yeah. Injection reports not generated, no defined. Oh, okay. This is this is what happens when you kind of dive through 2 different methods at one time as well, right? So I went through and I went back and actually assigned methods, the templates to the other one. So if I just do short, and we'll add this again real fast here, we'll just do that right there. So now I'll save that method. I'm going to reprocess all. Same thing with that. There we go. All right. So then we've got, so now we can view the PDF. So that's how you can view the PDF within the data analysis. So I don't have to go to the external folder. I can just look at what I've done here. And so now you've got your chocolate caramel, 2 peaks, you've got your area and your amounts and your concentrations that were all calculated out. Right? So that is your external report. So that is kind of your overall from beginning to the end workflow with the software platform. All right. So are there any questions at all with what we've done so far? Right.
Thanks, Matt. No new questions have come in here through the Q&A or chat. Mia, do we have any over the phone?
No questions, ma'am.
Awesome. So everyone is a pro at this. That's what I like to see in here. Okay, so to kind of, again, to wrap it up, right, we're kind of on the downswing of this. It's the master methods, right? It's the master methods versus result set method. The thing to really keep in mind is the result set method is in your result folder, all right? When you go through and you open up a result set in data analysis, you are opening up that result set folder. You are not opening up a master method that is in the methods file folder. Okay, and again, if you get confused as to which one is open, you can go and you can highlight the method in the data analysis, and we'll take a look at that again one more time when we're looking at the method. So, some of the tips to kind of finish all this up. Some of the tips for dealing with methods and loaded methods in data analysis. Close data sets that are not needed. Right. Try to keep your injection tree clean. If you're not working with the result set, go ahead and close them out. Just kind of keep the result set open that you're kind of working with, unless you're doing really a cross-sequence summary, right? So keep the methods closed. This 2.2 software platform automatically closes methods that are not being used, right? So it tries to help out and close methods that are not linked, because a lot of times you've got result set methods, and this happens a lot. You have result set methods that are named identical to your master method. So that's where it throws in a wrench. Sometimes when, say, down here I've got the LC-MS sample purity, I could have that listed twice, right? One would be my result set method, one would be my master method. So it's a matter of trying to keep track of what is the result set, what is the master. And again, hover over these, and it'll show you the folder location that they're at. If the folder location includes the result set, then it's the result set method. If the folder location just says methods, if it's your project name, the methods, it's your master method. So that's kind of how to keep those two together. All right. So for this last part, we're just going to show you how to close the data files. What happens when we set the processing method on? We've already done that. We've already kind of looked at doing that. That was one of the first examples of loading up a processing method. Instead of doing an area percent, we selected none. What could you do? Well, you could do everything, but nothing is automatically done for you, right? The software doesn't know the route to go until you tell it, okay, let's do an area percent, or let's do a quantitation method, 3D UV. All right. We'll take a look again at the method and the links, make sure we know what's linked up and what's not linked up. What happens when you load up multiple sets? We'll take a look at that, and then we'll select method, note the link to the file. So, all right, let me clean this up just a little bit. Okay, so what we're going to do is I'm going to do something that hopefully you guys will not do or prevent. I'm going to try to load up quite a few result sets. Let me see what all loaded. All right, so I got one. Okay, this is perfect. So I got one that had no process method tag to it, right? So if I go to none, again, you load that, I have nothing. It doesn't even try to integrate it. It shows nothing. There's nothing that's part of it. There's nothing it can do, right? But what it's showing here is it's actually showing a previous method. All right, so this method is not with the result set I just loaded. It's just listed a method from another result set, because I've got 3 result sets loaded here. Okay. So with these 3 result sets, right, if I'm confused about, if I need to know where this method is linked up to, right, the GCLC area percent, I can go and click on the method, and whatever is linked up into the pane is the data that's linked up to it. All right. So if I hit web calibration, well, it's the last one, right? And what if I click on one of these? Well, it's not linked up to either one, right? So that's the other tool here is, depending on if I'm clicking on a data file or a method, my chain is going to appear one way or the other, right? So if I'm clicking here, my chain appears on the method, it's not on the data file. But if I click on this method, it appears down on the data files and not on the method. So that's kind of one way to use that. And this is to kind of show you what's linked up with what, and it hopefully kind of gives you the idea of how to keep your space clean. If I'm not working with these, if I'm not working with either of these, let me just go ahead and close, right, and clean it up. Don't save it. Now I'm back down to 1. I've got a data player that has no method selected to it. So if I delete that, I still have my method, and I've got my information here. So are there any questions on this, on multiple data sets loaded up into the screen and making sure that your method is linked up to the right result set?
No new questions, Matt.
Okay.
Yeah, anyone over the phone line?
No questions.
Okay, awesome. So, yeah, we're kind of on the tail end of this, all right? So there's key points, all right? So in acquisition, what do you need, all right? You have to have a valid project. That was in session 1, right? So if you're missing the sections, we've got them planned out in the future, just like Rebecca said earlier. We've got them timed out so you can actually join into one of those and see how to create these projects. All right, it requires an instrument that's probably configured with a project. Again, I can't load an instrument without it being a part of some project. All right, then it has to have an acquisition method. All right, I won't even be able to hit the run button if it didn't have it. All right, and then you have single injection samples. What do those create? They create SI result files. Sequence samples create result files. All right, and then with data analysis, your processing method, you've got several parts that are within the processing method. You've got integration, manual integration that, as we saw, can be included into the processing method, but you are going to have asterisks beside those data files telling you this was manually integrated, right? So that's one thing to keep in mind there. The identification in the compound table, the calibration curve, some of the calculations, some of the external standards and how to create the levels. And then we looked at reporting, how to tag on 2 reports. What is automatic, what is manual? So those are some of the things we saw there. So again, to put it all together, create the project, you create and configure an instrument, you're creating an acquisition method. When you create the acquisition method, you're doing a single run versus a sequence run. And then in the data processing method, you have the integration, your compounds, your calibration, and your printing that are all involved in that. All right. So again, I've said it many, many times, the help and learning is incredibly useful. All right. Again, it's context specific. Wherever you're at in acquisition, data analysis, hit F1. There's a lot of useful information there for you, as well as the PDFs on the media stick, all right? A lot of guides, reference guides, application notes, different things that we use with the software. All right, and so then beyond this, we have the Agile University, which really it takes what we've done today. We only had a couple hours to do this, right? So Agile University takes that to another level, goes deeper and deeper into the different aspects of the software platform. It's incredibly useful. I highly recommend either diving into this yourself or having super users within your company or your lab to actually be involved in this, right? And so then you create super users that can, be specific learners on different parts, and then they can actually go and train some more people, maybe new hires, interns, things like that within your lab, because these, labs change. They change over time. So this is a very useful way to keep updated within your lab. And so finally, are there any questions at all over anything that we went over?
Well, thank you so much, Matt, for such a comprehensive presentation and all of those demonstrations for our audience. I haven't seen any questions come through at this point, so what I'm going to do is share some information on our upcoming live events in the series, and then we can take another look at the Q&A box. As we've mentioned, today's session is the second in this 3-part webinar series, and all 3 sessions will be running on a monthly basis right through to April 2018. The next live event on reporting that Matt has been referring to is taking place on November 28th. And I've just put up some information on session 1 for our December series, which will be on December 5th. So we hope to see you at some of those live events. To view information on future sessions in the series, for registration information, and to access recordings of previous events, you can always visit the website that's referenced at the bottom of the slide here. Following today's event, you will receive an email with a link to access the recording of today's event, so you can keep your eye out for that. Just take a final check of the Q&A log here, and Matt, it looks like we don't have any. Mia, do we have anyone with a question over the phone?
No phone questions, ma'am.
Okay, thank you. Well, Matt, it looks like we're reaching the conclusion of our live event. So on behalf of our audience, I'd like to thank you again for your presentation and all of those great software demonstrations today. On behalf of Agilent Technologies, I'd like to thank our audience for joining us today, and we do hope to see you at a future event. We will leave the session open for a few more minutes to receive any feedback or additional questions, but for now, we're going to close the audio lines. Thank you once again for attending, and from Agilent Technologies, we wish you